All right, we're going to talk about domain and range, talk about them together, even though they're slightly different, only in the sense of which variable you're worried about. Without further ado, here it is essentially in a nutshell. The domain is really all possible values of x. All possible values of x. That's what the domain is, right? Um, you could also say all possible inputs. That's a nice way of generalizing it. So I don't have to do a whole bunch of specific stuff. We could just kind of apply that every time we have a problem. Similarly, I'm going to do something similar, make a statement similar to the range. If the domain is all possible values of x, as you might imagine, the range is all possible values of y. All right, that's just what the range is of y. Well, remember, y corresponds to the outputs, not the inputs. So I'll say all possible outputs. All right. I mean, that's nice to say, but what we need to do is see how that applies. And to help us with that, I'm going to start with talking about some discrete domain and range. Remember in the previous video, we talked about discrete versus continuous. It won't specify a whole lot as you see them as you go, but I just want you to know the difference. Okay. I'm just going to skip through some of these. Like number one, I'm not worried about. It's about whether or not it's a function. Number two, all the values of all the y values are the outputs. We just said that's the range. That's good. All the values or the x values are the inputs. Those are the domain. That's good. Now, what's the range of the following relation? Remember, the range is the output. And remember, in every ordered pair, you have an x value and a y value. That's the output. That's going to be the range. So you're going to see this either the answer is written a couple of ways. You might see the set of and then have some numbers in it, or you just might see a list. So what I'm concerned about are the outputs. So -2, 3, 10, and 8. -2, 3, 10, and 8. Now, usually you'll see it listed in numerical order. It doesn't necessarily have to be, but it's usually that way. So you do not have to, the range is not, it is not an ordered pair. It is not an ordered pair. All right. It is just a list of numbers. It's all the possible values of y. Y will be a list of numbers, not an ordered pair. Same thing for the domain. You will not have an ordered pair. You might see a set of brackets, again, with a list of numbers in it, like -2 and 3 and 8 and 10. Both of those would work. And let's keep it moving. If I have this table, identify the domain of the following relation. Remember, the domain is the x values. So all I'm really looking for is a list of numbers that represent the domain. All right, it's -6, 0, 2, 4. I know these things have the points, but that's not the list of the domains. This is. That is the whole relation itself. That's not the answer here. That's a relation. All right, is this continuous or discrete? I do want to do that one. Because it's not all connected, this is a discrete graph. And I could ask you for the domain and range. If I ask you for the domain, you'll be looking for this number, whatever it is, this number, this number, this number, and this number on the x-axis. All right. If I were looking for the range, I would look for this number because I have points on that level, this number because I have points on that level, this number because I have a point on that level, this number and that number on the y-axis. All right, this is about discrete or continuous, that's fine. Is this discrete or continuous? That's fine. Okay, what about the domain and the range for number 10? The domain would be the set that has a 0, a 1, a 2, and a -4. And then the range would be the 1, -4, -3, and 1. All right, so 1 is in there twice, so you should expect to see it like this because it's in there twice. Not that because it has a -4. This one looks like it is the probable answer.